Assalamualaikum and good morning everyone. Good afternoon everyone.
Waalaikumsalam, Doktor.
Okay, so today we are going to continue with our lecture last week. So we stopped at lecture 4D, I think 4D, sketching root locus. So we stopped at example number 1. So we finished example number 1. Okay, so today we are going to look at example number 2 for sketching root locus and maybe some of the tutorials, and we will continue more on tutorials on this Wednesday. Okay, so example number 2. So let's say you are given this transfer function, a forward transfer function, gs equals k times s plus 2 divided by s squared minus 4s plus 13. So given a unity feedback system, okay, unity feedback system and forward transfer function. So this is the forward transfer function for a unity feedback system. And then determine the root locus sketch, the JW axis crossing, the K value at imaginary axis crossing, the breaking points, and also the angle of departure from complex poles. Okay, so when question gives you a transfer function, a forward transfer function for unity feedback system, so meaning that you can find the poles and zeros straight away from GS, okay, without using the method when k equals 0 or when k equals infinity. So from here we can find first our zeros. So our zeros is at s equals minus 2. And then poles. So s squared minus 4s plus 13 equals 0. So you need to use a calculator for this. So you will get s equals 2 plus minus 3j. Okay. So your poles is at 2 plus minus 3j. So after we found the zeros and poles, then we can calculate the other things like JW axis crossing and so on. Okay, so let's look at the answer given. Okay, so firstly you can sketch, you can plot the poles and zeros on the S plane. Okay, so here is the poles at 2 plus 3j and 2 minus 3j. Okay, and then the zero is at minus 2. Okay, since we have two poles, meaning that we have two branches of the root locus. Okay, so we have two branches. Maybe right here, two branches. And now we can calculate the other things. So the question asks you to calculate the JW axis crossing. So to find JW axis crossing, you need to do Route-Hurwitz criteria or Route-Hurwitz table. So firstly, you need to find the TS, okay, the closed loop transfer function. So it's a unity feedback. So G divided by 1 plus GH, and H equals 1 for unity feedback. So simplify. And then take the denominator. Okay, so take the denominator and do the Route-Hurwitz table. Okay, so this is the Route-Hurwitz table. And then from the Route-Hurwitz table, we look at row S1. Okay, row S1. and find the value of k when all of the value of row S1 equals 0. Okay, so we get k equals 4. So k equals 4 is the value of k at the JW axis crossing, okay, which answers question C. Okay, the value of k at imaginary axis crossing. So that value is k equals 4. And then we use this k equals 4, use it on row S2. Okay, so arrange row S2. So 1s squared plus 13 plus 2k. So 2 times 4. So use calculator, you get s equals plus minus 4.58 times j. So this is the imaginary axis crossing. Now we can find the breakaway points or break-in points. Okay, so to find the break-in or breakout points, we use this formula, okay, the summation of 1 over sigma minus zeros equals summation of 1 over sigma minus poles. Okay, so use your poles and zeros, and then you get sigma equals minus 7. So break-in points is at minus 7 here. Okay, so you can sketch the root locus because you have the JW axis crossing and break-in points. So always remember that your root locus always start at the poles, and then one of them will go to the finite poles, finite zero, which is at minus 2, and the other one will go to infinity. Okay, so you have 2 branches, okay? And then because we have complex poles, so we have angle of departure. So if you have complex zeros, then you have angle of arrival. Okay, so to find angle of departure, so firstly you need to find the angle made by, for example, we want to find this angle. So we have to find all the angles made to these poles from the other zeros and pole. Okay. And this one. So this angle is 90 degree, and this angle you need to use tangent. Okay, so this is the formula. So angle of 0 is tangent 3 over 4. Okay, so the sisi berjauhan bagi sisi sebelah. Aside, apa tadi English dia lupa dah. Opposite aside word. Okay. And then angle of poles is 90 degree. And then minus 2k plus 1. So ignore the 2k plus 1, just use 180 degree. Okay. So this only represent dia punya rotation. Okay. So use 180 degree. So you get negative 233.3 degree. So this is measured negative, meaning that measured from here, okay, negative x-axis. So you take the positive part, so it's it will become 126.7. Okay. So the angle for the bottom poles also the same. Okay, with the top one, because it's symmetry about the real axis. Okay, so the reason for finding the poles is finding the angle is to make sure that you plot it correctly. Okay, sometimes maybe you don't know where the root locus will go. Okay, maybe going at different angle and so on. Okay, so example dalam slide ni simple je. Okay, dia tak nak bagi example susah. Okay. And this is the final plot of the root locus. Okay. So one branch will go to the 0 and the other branch will go to infinity. Okay, any question before we go to tutorial? Okay, so let's do tutorials related to sketching root locus, tutorial number 11. So before we go to this tutorial, let's recap a bit about the properties of root locus. So properties of root locus. So first one is root locus will start at poles and end at zeros. And then number two is number of branches equals number of poles or zeros. Okay. And then third one is symmetry about real axis. And then number four is axis on odd number of poles or zeros. Okay, so the first four rules are will determine or will decide on the shapes. Okay, on the shapes of the root locus. So for the first four rules, it doesn't involve a lot of calculation. Okay, so rules number 5 will be about JW axis crossing. So this one you need to use Rutherford's rules number 6 is asymptote. So for asymptote, we have two formulas. So first one is the real axis intercept. So summation of poles minus summation of zeros divided by numbers of poles minus numbers of zeros. And then number 7 is breaking points. Oh sorry, asymptote tadi ada formula satu lagi. So another formula is the angle of asymptote. It's 2k plus 1 pi over number of poles minus number of zeros. And then we have breaking points. So breaking points, the formula is summation of 1 over sigma minus 0 over summation of 1 over sigma minus poles. So we want to find sigma. And then rules number 8 is the angle of departure, arrival. So this is for complex poles and zeros. So the formula is angle equals angles poles minus angle 0 plus 180 degree, or and 0 minus angles poles. Okay, I think this is for arrival, this is for departure. Okay, so let's look at the question given to you in tutorial 11. So sketch the root locus for the unity feedback system with a forward transfer function g given here. So there are 3 questions. By determining the following if this exists, okay? So you need to determine asymptote, breakaway or breaking points, JW axis crossing, range of K for stable system, and the angle of departure and arrival. Okay, so only all of these are exist, okay? But sometimes they might not exist in the root locus. Okay, so this is a unity feedback system, forward transfer function. Okay. So let's look at question number 1 first. Okay, so firstly, you need to find the poles and zeros. So poles is at s equals minus 2 and minus 4, and zeros. So I think you need to use a calculator for this one. So you get zeros at s equals 2 plus minus 4j. Okay, so we have 2 poles and zeros. So meaning that we have 2 branches. Okay. Then we can roughly sketch the poles and zeros on S-plane. Okay, and then determine in which part of the real axis will have the root locus. So in this section, there will be no root locus because there are 2 zeros, okay? Even number of zeros. For this section, you have 1 pole and 2 zeros, meaning there are 3 things. So it's an odd number. So you will have a root locus on this real axis. And then on this section, you have 2 poles and 2 zeros, meaning that there is no root locus on the real axis. Okay, so the root locus will exist on the real axis at this part only. So we can get a rough idea on what the shape will be. So this is if you have done a lot of root locus sketch, you will be somehow familiar about the shape of the root locus just by looking at the poles and zeros on the S plane. So here it will look something like coming out here. And then there will be a breakaway point here. And because there are two branches, and then one of them will go to the zeros, and the other one will also go to the other zeros, okay? And it will intercept this JW as this crossing. Okay, so roughly the shape of the root locus you will get is something like this, okay? But let's continue. So the next things that you need to calculate is the asymptote. So here in this root locus, with this kind of shape and breakaway point here, so there is no asymptote, okay? There is no asymptote for this kind of root locus. So you don't have to find asymptote. Okay, so most of the time, asymptote will not exist for a system that has two poles and two zeros, okay? Most of the time, it doesn't have asymptote. So for this shape, you don't have asymptote. So we don't have to find the asymptote. So we go to question B, breakaway and breaking points. So here we only have breakaway points, okay? We don't have breaking points. So let's find the breakaway points. So breakaway point. So 1 over sigma minus 2 minus 4j plus 1 over sigma minus 2 plus 4j equals 1 over sigma plus 2 plus 1 over sigma plus 4. So you can calculate this. So sigma squared plus 6 sigma plus 8 sigma minus 2 minus 4j plus sigma minus 2 plus 4j. Okay, so if I calculate like quite fast, okay, don't worry because this is not a mathematics class. So you can do it yourself later, okay? Okay, so equals sigma squared minus 4 sigma plus 13 times, plus 20 plus sigma plus 2 plus sigma plus 4. Okay, so you can calculate it slowly or you can use calculator. I think you can find this using calculator. So here we get 2 sigma minus 4, 2 sigma plus 6. So we get 2 sigma cube plus 12 sigma squared plus 16 minus 4 sigma squared minus 24 minus 32 equals 2 sigma cube minus 8 sigma squared minus 24. Salah. Minus sigma squared minus plus 40 sigma plus 6 sigma squared minus 24 sigma plus 120. Okay, so we can cancel out this. And then add up. So 10 sigma squared eight sigma. So minus 88. So now I can use calculator. So we get sigma equals minus 3.39 and 2.59. Okay, just double check. Okay, so we have two sigma breakaway and breaking points, but we need to choose only one because from the sketch, from our early sketch, we see that only one breakaway points here. Okay, it's here between minus 4 and minus 2. So we choose this one. This is our breakaway point. Okay, but this one is not, okay? Okay, so we get our breakaway point. And then now we can continue by finding the JW axis crossing. So to find the JW axis crossing, you need to find the closed loop transfer function. Okay, so this is forward transfer function, GS. So we need to find the closed loop transfer function. Okay, so closed loop transfer function TS equals K times S squared minus 4S plus 20 divided by S plus 2, S plus 4 plus K times S squared minus 4S plus 20. Okay. So we need to find the denominator. So simplify, so we only take the denominator and expand, okay? So here we get S squared plus 6S plus 8 plus K times S squared minus 4S plus 20. Okay, rearrange according to the S squared, the S, okay, the S terms. So we get K plus 1 S squared plus 6 minus 4K times S plus 8 plus 20K. Okay, so this is our denominator arranged in S terms. So you can do the Rapp-Hurwitz table. Okay, so start with S squared and S1 and fill it alternatingly. And then for row S0, you use the determinant. So here I get 8 plus 20k. Okay, so to find the JW axis crossing, we use row S1. So 6 minus 4k equals 0. So k equals 3 over 2, okay, 6 over 4. Okay. Betul. And then from this k, you use row S2. So 3 over 2 plus 1 times S squared plus 8 plus 20, 3 over 2 equals 0. Okay, simplify. So here you get 2.5 S squared plus 38. So use calculator. So S equals plus minus 3.9 J. So you can take this value and see on the sketch. Okay, so it's somewhere here. Okay, supposedly here. Yang bawah ni betul lah, lebih kurang. Okay, so this is the value of K at JW axis crossing. This is the JW axis crossing. And then the question asks you to find the range of K for stable system. Okay, so for stable system, if you look at the root locus, so passing this on the right hand side here, when the root locus crosses the JW axis, so the system after this point will not stable, okay, will be unstable. So the system is will stable when K has value less than the value at the crossing, okay, or the value at crossing is given at K equals 3 over 2. But what is the lower limit? Okay, so we have this limit 3 over 2, but what is the limit below that? Okay, so we need to use the width table that we have assembled. Okay, so firstly we look at so we get K must be less than 3 over 2. Okay, so this is from row S1. And then from row S0, 8 plus 20k must be positive. So we get k bigger than negative 8 over 20. So 2 over 5. And then use row S squared. So here k must be bigger than minus 1. Okay, mana satu nak pilih ni? So we can do number line. Okay, so on this section, all of the lines intersect each other. Okay. So the range between these are the range of K for stable system. So range of K for stable system terlebih M dia is negative 2.5 K 3/2. Okay, so this is the range of K. But sometimes most of the time we don't take K equals 0. We don't take negative K, okay, negative value of K. So sometimes in books, they will just take this range, okay? Because we normally don't take negative K, okay? But for the top answer here, it is more correct, okay, than the bottom one. The bottom one is more realistic. In real life, we don't take negative gain, okay? We only take positive gain. And now we have the answer for question D. And then lastly, question E, angle of departure or arrival. So let's look at our sketch. So in our sketch, we have complex zeros. We have complex zeros. So meaning that we only have angle of arrival, okay? Because angle of departure are for complex poles, and angle of arrival are for complex zeros, okay? So now let's find the angle of arrival. Okay, so what you need to do is you need to find the angle from these poles and from these zeros, or the zeros that you are interested in, and then find the angle from the other poles and zeros. Okay, so we need to find theta 1, theta 2, and theta 3. So theta 1 is 90 degree because it's just directly below the angle that we need to find, the zeros that we need to find. And then theta 2, you just use tangent. So tangent minus 1, it's 4/4. Tangent 1. So tangent 1 equals 45 degree. And then theta 3 is tangent minus 1, 4/6. So you get 33.69 degree. And then use the formula. So angle of arrival equals, okay, tak ingat formula dia, tengok lecture notes. So 180 plus angle number 2, angle of poles, plus angle of the second pole, minus angle of 0. So you get so it's 168.69 degree. So it's somewhere here. Yep. Soalan ke?
Sir, yang saya cakap tadi kita cuma ada angle of departure ke arrival?
Arrival. Sebab kita ada complex zeros. So complex zeros, angle of arrival. So kalau complex poles, angle of departure. Ya, angle of departure atau arrival for complex poles atau zeros. So departure untuk poles, arrival untuk zeros.
Maksudnya yang kita punya zero tu duduk dekat belah kanan kan sir?
Belah kanan, cuma dia punya sudut root locus tu nak masuk ke zeros tu. Itulah angle of departure dan arrival. So dia
Okay,
roughly 168, okay, 169 degree. Okay, so we get all of the information, so we can sketch the root locus. Sampai 4J. Okay, sketch ni seeloknya lukislah cantik-cantik. And then we have the asymptote. Asymptote tadi kat mana tu? Asymptote pula tu. Breakaway points 3.39. So it should be somewhere here as a breakaway point. And then the J omega axis crossing 3.9J. So it should be here. Okay, so we can try sketch. So one root locus start here. And the other one will start from this pole. And then it will break from this breakaway point. Okay, so one of them will cross this. Okay, so it will enter the zero at 169 169 degree. And then the other one. Okay, so similar. Buruknya root locus. Okay, so this is our root locus. So make sure that the arrow showing the root locus starts from poles and then ends at zeros. Okay. Okay, any question? So ni
Sir,
tadi.
jadinya root locus tu dia tak semestinya bentuk bulat tepat-tepat lah sir?
Dia macam parabolik lah. Tapi sebab ni lukisan kita panggil sketch. So dia tak adalah akan salah shape tu. Just make sure that you draw bentuk yang simetri lah. Okay. Janganlah kat atas straight, Bawah tu melengkung. Ni buruk sangat. Macam tu lah.
So yang dekat negatif 3.39 tu breakaway ke break in?
Ni breakaway. Breakaway sebab if you look at the root locus, dia start dari poles, so dia kena keluar. Dia kena keluar dari real axis. So when it goes out, meaning that it breaks away, okay? Dia break away lah, breakaway points.
Okay sir.
Sir,
Yep.
nak tanya,
Yeah.
kan mula-mula tadi kena cari poles dengan zeros kan? And kena cari pakai calculators kan sir kan?
Yang ni.
Kenapa saya tak dapat nilai sir? Macam ni saya tekan calculator tu?
Ni. Mod shift 5. Mod 5 quadratic equation. Tu dapat lah. Tak nampak kat sini.
Oh, saya tekan mod 5?
Mod 5 lepas tu kan dia jadi quadratic equation.
Lepas tu masukkan nilai dia tu?
Mod 5 tu nombor 3. Lepas tu dia minta ABC. Tu isi je lah.
Oh, tu je lah. Okay. Okay sir. Terima kasih sir.
Okay. So for root locus question, usually you will get marks for this, okay? If you find poles and zeros, maybe 1 markah. So if you don't know the rest of the calculation, cari ni pun okay dah. 1 markah. Okay. I think most students usually they will start at kalau dalam exam lah, usually we don't give this. We don't give the GS. But instead, maybe we give you a block diagram. You need to simplify block diagram to get GS. Okay. So most of the time, student cannot simplify the block diagram. Okay. So when they cannot simplify the block diagram, dia hilang semua markah lah for this question. Or maybe we give this. Maybe we ask you to find GS from gear system ke, or mechanical system, and then from there you can find poles and zeros and sketch the root locus. Sometimes if GS is given, students couldn't find the rest of the things like breakaway points. When maybe they manage to get this equation correct, but they don't know how to simplify. Okay. So you can simplify this, I think, using calculator. If in calculator, I think you can use the shift soft. There's a soft function written in your calculator. Okay, so try, if you have time, try to look at YouTube how to use the soft function in your calculator. So instead of simplifying by hand, you can use the soft function. But you are doing this online test, kan? If you are so smart, you can sketch the root locus using MATLAB first, okay? And then you can just calculate your answer and validate your answer with MATLAB. Okay, that's even easier. So that's why your project part 2, project number 2, one of the question, part 4 is about root locus. Okay, so you can start doing project number 2 on root locus. Okay, so to get familiarize yourself with how to sketch root locus. And I think for the JW axis crossing is quite easy because this is as I told you last time, I want you to by now know already how to do the Rabb-Hurwitz table and find the range of k, find the value of j omega crossing. Maybe you will get confused on finding the closed loop transfer function. Okay, but this is only mathematics. It doesn't involve any control, okay, or any theory here. So if you don't know how to find this, pergi cari. And then the another things that may be difficult is finding the angle of arrival and departure. Okay, maybe you will confuse kat mana angle dia, but most of the time when you've already found the angle of departure, it's not really important in the sketch. Okay, tak berapa penting pun dalam sketch. It's very minor. Okay, very minor when it comes to sketch. But in theory, we still give this this question. Okay, because finding the angles are also important later in the next lecture. Okay, lecture 5, chapter 5, because when designing a controller later, you need to find some angles. Okay, so here it's like a practice for you to find the angle. Okay, using tangent and so on, just like a refresh. Okay, how to use tangent and how to use the concept of 180 plus angle of poles minus angle of zeros. And then if you cannot find angle of departure or arrival, please make sure that in your test or in your exam, you sketch your root locus. Okay. Some students, when they plot zeros and poles, they don't put the symbol circle for zeros and cross for poles. Okay. So this is similar to some of you that do project 1. So in project 1, some of you didn't put cross to represent poles. When the question says plot the poles on S-plane. So you just sketch S-plane, like for example S-plane, and then you just put here in -2, and then you write S-plane. So what is this? There's nothing here. So some of you lost marks from S-plane. So just put cross, you get 1 mark. Okay. So if you don't put cross and circle, hilang markah macam tu je. Okay, so I think we can continue more tutorials. We still have 2 questions on Wednesday. And as a reminder, you can now start doing your project number 2, part 4. Okay, part 4 is about root locus. So based on project 1, some of you that do MATLAB and calculation didn't validate between the calculation and MATLAB that you found using codes. Okay, so if you put in table or explain why there's a difference between your calculation and MATLAB, you get extra marks. So that's why in project 1, some of you get higher marks, some of you get quite low marks, because in MATLAB you just put codes without explaining what you are doing. So in part 4, for root locus, you are required to sketch root locus in MATLAB and find all of the necessary properties. Okay, there are 8 properties. So you can validate your calculation using the plot that you get from MATLAB. Okay, so if you put in table, adalah markah. Okay, like this is your calculation and your MATLAB. So what you get, and then maybe the difference ke, and then explain sikit, you get better marks. So if you just put table, maybe less marks. Okay, so because your project and your quiz are just like a free marks. Okay, memang final tu susah. Okay, tak boleh buat apa. Memang final, even it's 40% last time, student barely score 70 and above. Okay, so if you want to pass this subject, please do your project and quiz properly. Okay, that's it for today's class. Any question before we end this lecture? Okay, so if you don't have any question, then see you on Wednesday, inshallah. Assalamualaikum and goodbye.